Hi guys, we are going to study semiconductors. So, we will this chapter the semiconductors chapter. So, as I already said, this chapter is like really simple and you can learn it it's a really simple chapter. So, this is the chapter, so that is semiconductors. So, what do we know about semiconductors? So, first thing you have to know is about conductors. So, you have to know about what is conductors, then you have to know what is insulators. Then only you can jump into semiconductors. So, that's the first thing. So, so what is conductors? So, what are conductors? Conductors are substances which can be used, or they are materials which allows the flow of current through it. Now, what are resistors? Resistors are substances which does not allow the flow of current through it. That it resists the flow of current through it. So, the substances. So now I'll just erase this one. One second, I forgot my. Yeah. So. Okay. So now the next thing is wait what? Okay. So first thing you have to know is what are conductors. Conductors are like such things. It allows the flow of current through it. So what happens is that the conductors allow the current to flow through it. So such a thing is called as conductors. The second one is resistors. What are resistors? Resistors are basically nothing but the opposite of conductors. That is, it does not allow the flow of current through it. So resistors, this is the current flow I. So it is not allowed in the case of resistors. So this is conductors and this is resistors. So these are the two things you have to learn first about electronics. So these are the two compounds which you are familiar with because you have studied in class 10, 11th, etc. So now the next thing you have to learn is about semiconductors. So in our semiconductors. So the main thing I will do is I will give an explanation in English, and which will be primarily followed by an explanation in Malayalam if required, because if it's like concept I need to say it in Malayalam, but basically the class will be taken in English only. So because that would be more useful for all of the audience of all the parts of the world. If I'm like talking like that, if I'm taking into consideration all the people, then this might not be the best class, but I know I can do my best, and that will bring a change in lots of the people who are listening to these videos. But for that I need to communicate with others in such a way that all are able to understand what I am saying. So for that reason and that reason only, I am speaking in Malayalam, not in Malayalam. I am speaking in English and taking my class in English only. But I will definitely say Malayalam explanations in between them if required. But just be provided, I will definitely take the explanation in English only. Then if further explanation is required only, like I will just transcribe it as Malayalam. Okay, that's the only thing I am going to do for Malayalam. So this is the thing. So now what are semiconductors? So that's our chapter. So what are semiconductors? Basically, semiconductors are neither conductors or insulators. They fall in between the category. That is, it allows the flow of current, but it doesn't allow the flow of current. How can that happen? Well, the thing is, the semiconductors have a special property in them. That is, they are more conductive than resistors. That is, they allow the flow of current more than the resistors, but they allow the flow of current lesser than that of the conductors. You got me? Like it has more conductivity than a resistor, and has less resistance than a conductor. Yeah, that's exactly what I'm saying, and that's correct. So basically, okay. So basically, you have a conductor, and that conductor allows the flow of current through it. And no, I will say in English only because there's no need for this, because definitely Malayalam will be there, but I will, if there's an important explanation, I will say it in Malayalam, but right now English is best. So the thing is, what are semiconductors? I need you to understand this really clearly, that's why I am repeating again and again. Semiconductors are only simple things. They are more conductive than resistors and less resistive than conductors. Okay, like they allow the flow of current more than the resistors, so hence they cannot be classified as resistors, but they cannot be classified as conductors also, because they are more resistive than that of the conductors. That is, they do not allow lots of current to flow through. So this is if this is insulators or resistors, but it's the same, but I should use the word insulators because that's a technical term. I didn't introduce it right now because I need you to guys to be familiar with the word conductance and resistance. That's why I use the word resistance. So the actual word you should use is insulator, and you also have conductor. Now where does semiconductor lie? They lie in between, because they are more conductive. That is, they allow more current to be flowing through them than that of the insulators. So they are not insulators, but they allow it to a certain limit, and hence they cannot be considered as conductors because they do not allow all the current to flow through it. Like if I give that example, you will be kind of confused, so that's not necessary right now. So this is the semiconductor. So this substance or this material can be referred to as semiconductor. So this is like a intermix of both the resistors and the conductors. Now I have said a lot about conductor or semiconductor and resistor, insulator also. So the thing is, since I have said this much, why I have said this much or I have wasted this much time is because definitely the time is not wasted. Since this is like a base concept which you require in this chapter, unless why you cannot understand what I am saying after this. So now I will be going a little bit fast. What is this? Okay, so again, one more time, one last time, what are semiconductors? Semiconductors are substances which partially allow the flow of current through it, or semiconductors are substances which have good conductance but cannot be classified as an ideal conductor. And these substances lie between the insulators and the conductors. Okay, so this is the basic concept behind semiconductors. Now we need to understand certain characteristics of a semiconductor. So the first character is that they have, as I said, characters. What are the characters of a good semiconductor? So what is that? It has this higher, okay, higher conductance than a resistor. So it cannot be classified as a resistor. The second one is it has lesser conductance than conductor. Third one, so this I already explained these 2 points. The third one is like really important, like they all have a valence shell which has 4 electrons. So you have the outermost shell and you know an atom. So this is like an atom and this is the it's a nucleus. Okay, fine. So I will not do anything, I'll just shade it, I guess. Okay, so this is it, and if I am drawing like orbitals, and then if this is the outermost shell, right? So this outermost shell can be said as the valence shell. So that's the basic thing. You have the outermost shell, and that is called as the valence shell. And this valence shell always has 4 electrons. So 1, 2, 3 and 4. So if the valence shell has 4 electrons, then like only the compounds having the 4 valence shell electrons as 4 can be semiconductors. Okay. So that's one thing you should be definitely have so as to become a semiconductor or be a semiconductor. So valence shell has 4 electrons. So this is another thing. Now the third one is like temperature coefficient. So what is temperature coefficient? There is no need to worry. It's a simple thing. So first I'll write the point because I need to write this because I don't have the space, or else I'll do what I'll do is I'll use this space. Okay, I am using this space. So you have already learned the formula. Alpha is equal to T. Let me guess. Let me remember. I can check in the notebook, but I want to remember and tell you guys. 2 minus R1 by T1 R2 minus R1 by T1 R2 minus R1 R2 minus R1 by R1 T2 minus R2 T1 R1 T2 yes R2 minus R2 minus R1 by R1 T2 minus R2 T1. Yes, that's exciting. So this is the formula. Alpha is there, and this alpha is called as a temperature coefficient. So this temperature coefficient can be referred to or written as R2 minus R1 equal to this is a really important formula. So you have alpha, which is equal to R2 minus R1 by R1 T2 minus R2 T1. This can be referred to as the one second. Sorry guys, so I was like actually the truth is my father called me, that's why I went. So the next thing I have learned is that, and on the way I ate some mixture also. So you have this one. So what is the formula for that? So what is alpha? Alpha is equal to temperature coefficient. So what is temperature coefficient? It's just a there's no need for you to actually learn the meaning of it, but it's like a coefficient which is used in thermodynamics. Okay, so that's alpha for you. So what is alpha? Alpha is equal to R2 minus R1 by R1 T2 minus R2 T1. What is R? R is resistance and T is temperature. So R2 minus R1 by R1 T2 minus R2 T1 is the formula which you need to use to find the temperature coefficient. That's all you need to know. If you need to find the temperature coefficient, you have to know the formula that R2 minus R1 by R1 T2 minus R2 T1. Say with me, R2 minus R1 by R1 T2 my R1 T2. Let's learn like a little different, you know. Okay, just remember R2 minus R1. Okay, R2 minus R1 by R1 T2 minus R2 T1. Okay, so R2 minus R1 by R1 T2 minus R2 T1. Just remember that since R is the numerator, you will have the first term as R and also the first term as R1. So you have to just remember that, and the rest of the formula will come to your mind. So alpha is equal to R2 minus R1 by R first term, so R. Then you can write it as 1. So R1 T2 minus R2 T1. Now the same sign for both. Just remember like that. Same sign for both. R in the denominator, just remember this one, R2 minus R1. Then you have to remember that R2 minus R1, so R will be there, so R is here. Then that one will come, so R1 T2 minus R2 T1. Because since I write R first, so it's 1. So R1 T2 minus R2 T1. So this is the way of remembering the equation. So alpha is equal to R2 minus R1 by R1 T2 minus R2 T1. So this is called as the temperature coefficient. Now what are the examples of semiconductors? So these are the three properties a semiconductor should definitely have, and the fourth is that it should have a temperature coefficient which is negative alpha. Okay. So these are the 4 points which it should definitely have so as to be a semiconductor. Or a semiconductor will have all these characters. A semiconductor will have conductance which is greater than that of the resistor or insulator, and it will have less conductance than a conductor. Then it will have valence. In the valence shell it will have 4 electrons, and finally you have the temperature coefficient. So the temperature coefficient alpha will be negative for a semiconductor. So that's the thing you have to remember while doing this, while talking about semiconductor. So what is semiconductor? Semiconductor is a substance which partially conducts electricity, and you could say that these are the 4 characteristics of semiconductor. The first character of semiconductor is that it has more conductance than an insulator. Second property is that it has less conductance than a conductor. Third property is that the valence shell has 4 electrons. The fourth property is that the valence shell has 4 electrons. And the fourth property is that the temperature coefficient will be a negative value. So what is the temperature coefficient? Temperature coefficient is alpha, which is given by the equation R2 minus R1 by R1 T2 minus R2 T1. So this is the first section. This is the introductory section for the semiconductors. So now I can write this thing. So I hope you have it. If you can just take a screenshot of this. So this is it. So now I can write this. Now the second thing is one thing you have to learn. Okay, let me clear it. So the next thing is, how can you increase the conductivity of a semiconductor? So basically, if you have a semiconductor, how to increase conductivity of semiconductor. So how can you increase the conductivity of a semiconductor? So you have the semiconductor like this. This is a semiconductor, and the thing is, if you want to increase the conductivity of a semiconductor, you have to add impurities to it. So by adding impurities to a semiconductor, you can increase its conductivity. So how can you increase the conductivity? You can increase the conductivity of a semiconductor by adding impurities to it. So I am adding some impurities, and the conductivity of the semiconductor will be increased. So this is the basic method of increasing the conductivity of a semiconductor. And what is this process? This process is referred to as doping. So this is doping, and this property, or not this property, this process is referred to as doping. So what is doping? Doping is the process of adding impurities to the semiconductor so as to increase its conductivity. Once again, slowly. What is doping? Doping is the addition of impurities to a semiconductor so as to increase the conductivity of the semiconductor. So that's the basic definition for doping. So now you can note this also down. Just take a screenshot of this. Okay. Now the third is the type of impurities. So now you have the heading as doping itself, and the types of impurities. So the third thing is in the process of doping, you add the impurities. So there are two kinds of impurities which you can add. So the first one is a pentavalent impurity and the second one is a trivalent impurity. So pentavalent impurity as well as a trivalent impurity can be added. So it's like pentavalent. Okay. Okay. Can I ask you a question? Didn't I say that only 4 electrons can be there in the valence shell? Then how is it that it's pentavalent or trivalent? Pentavalent means 5 electrons in the valence shell. Trivalent means 3 electrons in the valence shell. How can it be there? I said that 4 electrons should be there in the semiconductor, right? This is a basic problem. So now what I am telling you, you should remember this really clearly. Okay. Now what I am going to tell you is, I just tried to confuse you. I said that the 4 electrons should be there in the valence shell for a semiconductor. For a semiconductor, the valence shell should have 4 electrons. But is this a semiconductor? No. This is impurities. And this impurity is pentavalent or trivalent. So the impurities can be pentavalent or trivalent. I didn't say about that. I just said that the semiconductor should have 4 electrons in the valence shell. Okay, is that clear? Is that point clear? So the next thing is the types of impurities. The types of impurities include the pentavalent impurity as well as the trivalent impurity. So what is a pentavalent impurity? In the pentavalent impurity, you will have 5 electrons in the valence shell. I don't need to draw it here, right? And maybe I'll just draw this like the orbital, outer orbital only. Okay, that's it. So this is a pentavalent impurity and this is a trivalent impurity. What is it? There's 3 electrons in the outermost shell and there's a valence shell. And in this one, you have the 5 electrons in the outermost shell. So that's a pentavalent impurity and that's a trivalent impurity. Now, the next thing you have to learn is okay, next you have to learn about the examples of pentavalent and trivalent impurities. So for this I have already created a really good idea. So it's not recommended, but there's like a game which is played by all of the people, like all the teenagers, like it's a kind of game, and I know you guys know it also, PUBG, right? But I'm not talking about a PUBG, I'm talking about a similar game that is BGMI. That's like Battleground Mobiles India. That's a game in India that's like clone of the PUBG game. So what is it is like BGMI, and I know the boys here will definitely remember this thing. But I have not played this game. I have played Free Fire. Okay, just forget about it. So the thing is, this BGMI, it can be used for us for learning the examples of trivalent impurities. How you know? Well, just remove the N. Okay. To get BGI. This BGI can be the examples of the trivalent impurities. So this BGI is the examples of trivalent impurities. So what is the trivalent impurity? You have boron G, that is the gallium, and you have the indium. So boron, gallium, indium are the examples of trivalent impurity. Hence you have remembered it. Also another way also you can remember, it's BGI is an example for a trivalent impurity. How? BGI is BGI. 3 terms. So trivalent impurity. Simple as that. Okay. So BGI 1, 2, 3. So it's a trivalent impurity, and hence you could say that what is the examples for the trivalent impurity? You have BGI. What is BGI? BGI is boron, gallium, indium. And the third thing you have to remember is trivalent impurities. How do I know? I remember BGI. Oh, that guy said BGI, but I don't know if it's trivalent impurity or pentavalent impurity. How can I remember it? Trivalent impurity. I said BGI 1, 2, 3. Trivalent impurity. It's not a pentavalent impurity. It's a trivalent impurity. Now, the second thing is, so, I should not have erased that, right? I am stupid. Okay, fine. I'll draw it just like this. boron, gallium, indium. The second one is the pentavalent impurity. So just remember the code name BGMI. Just forget about this. Erase. Then you have boron, you have gallium, and you have indium also. So this is the method of. So this is trivalent impurities. Now you have pentavalent impurities. So what is pentavalent impurities? Basically nothing but you have 5 electrons in the outermost shell, and that is the valence shell. Now you have the examples of pentavalent impurities, which include, you could just remember is this one. Like I have got a way of remembering this also. It's PA square. PA square. So just remember PA square. So what does PA square stand for? P comma implies PA, pa, or just remember pa. Okay, I guess pa is easy to remember. Pa. Okay, I remember pa. Or okay, remember pa. Pa. Okay, for pa and BGMI, pa. So what is pa? Pa is PAA, and this P stands for phosphorus, arsenic, antimony. Phosphorus, antimony, and arsenic. So these are the examples of pentavalent impurities, and these are the examples of trivalent impurity. So hence you have learned it. And if you ask me how do I remember that PAA stands for pentavalent impurity, just you studied trivalent impurities, so you know that there are only 2 types of impurities, trivalent and the pentavalent one. So if you get like the trivalent impurities and you know that the trivalent BGI stands for trivalent, then you will be able to say that PAA stands for pentavalent. So that's like, just remember one of them, other will come to your mind automatically, because there's only 2 of them to learn. Okay, so just take a screenshot of this if you want. It's like quite ugly, but if you want you can take it down. Okay, that's it. So now take it down, like just take a screenshot of something like you could remember it easily. Okay, so that's the end of the first section. If I just finish one more topic, then that's the end of the first section of this chapter. I'm not saying that video ends here, I'm just saying that the section ends here. So the next topic or next point is that what is intrinsic semiconductors and what are extrinsic semiconductors. So basically you just have to remember that if there's an, what is this? So we have intrinsic, extrinsic. So what is intrinsic semiconductor and what is extrinsic semiconductor? Well, intrinsic semiconductor is a semiconductor which has not undergone its the doping process, and it's a pure conductor. Okay. So this is like an intrinsic semiconductor and this is an extrinsic semiconductor. So what are the difference? Intrinsic semiconductor is a pure conductor and extrinsic semiconductor is an impure semiconductor. I also have a way of remembering this also. Just remember IP. So how can you remember IP? Because you have one of the subjects of the subjects of class 12 as IP. You have one subject, informatic practices, right? Just remember that. Informatic practices IP. And so IP stands for intrinsic pure. Intrinsic pure. Intrinsic pure. So that's a way of remembering. I don't have any other way of remembering, or just by hand. It's like simple one, right? You could remember it. If not, you just remember IP. That stands for intrinsic equals pure. Pure. Extrinsic is impure. So the thing is, always just study one of them. If there's only two things in a scenario, just study one of them, and the other will come to you opposite, because it's the opposite of the other one, right? Definitely, if you study one of them, other will come automatically to you. So just study one of them. That's the better way to do it, and that's the easier way to do it also. So just take a screenshot of this. Okay. So now you have completed the first section of what is our semiconductors. Now we need to go into detail about what is an N-type semiconductor and what is a P-type semiconductor. So what is an N-type and a P-type conductor, which will be in section 2. Section 2, not session, section. Okay, so 2 minutes rest for me and just come back.